All right, happy Tuesday. We have like 3 more classes of core content this semester. We are right on the edge. What we're doing today is talking about interaction models, which are an extension of the core model we've been talking about. So we're going to do that at the beginning. Then I'm going to show you how I would set this up as a final project. So this will be, you can think of this almost as an example of how I would get started with a final project. So I'm going to start with a data set. I'll show you sort of some ideas of where we get the data sets. I think almost all of you are in a place at this point with final projects where you already have your data set, you already have done some stuff with it. I think the Part 4 project is showing me that. So the work you've submitted is a lot of this already. But I just want to walk you through some of the steps I would go through just to get started. And then we're going to build a couple of models. Then the last part of the class, I think we'll probably be finished maybe 45 minutes in. So the last part of the class, I want to spend having conversations with as many of you as possible about your final projects. This is usually very productive at the end of the semester. You'll run into questions and problems along the way with your final projects. We're in the place where we're making the turn towards thinking almost entirely about the final projects. So this is a good time to start getting set up with those things, thinking about the requirements for what we're doing at the end. So today we have 2 classes next week. No, this is Tuesday. We have today, we have Thursday, and then we have Tuesday next week for new model content. And then everything after that is focused on the final project. So this is a good time to start orienting yourself for that. We have mini exam 5, which is going to be on Thursday next week. I'll send out more details about that. The demo is already posted. I think this video doesn't glitch out halfway through. And I'll give more information about that as we get closer. And then we're done with exams. The rest will just be your final project. This, I think, is the most fun part of the semester. We save it for the end because it's the most fun, right? So we'll talk more about that when we get closer to the end. I'm posting, homework 5.1 and 5.2, which are using a data set that you've used before. But we're, over the next couple of homeworks, we're going to start adding complexity to an existing model that you've worked with. So that's where we're going. This is a picture of Maxine. Have I told you I had a child over the summer? Okay, that joke is totally lost, never to be revived again. She's almost turning 1, which is wild to me, in May. So you won't be in my classroom at that time, but we'll throw in a big party. So yeah, that's where we're going. Homework 5.1, 5.2 will be due at the end of the week. I might actually just give you the automatic extension through Sunday. Would that be nice? Okay, let's make it due on Sunday. I don't personally care that much. Let's see, any housekeeping I'm forgetting about? Anyone running the marathon? No? Okay. All right, so should we talk about a new model? Okay, I'll take that. Are y'all tired? How's it going? It's April, so these are the feelings in April every year. It's also not nice outside. So, I mean, I guess it's sunny. So there's that. Okay. Well, nice having a little chat with you. Small talk is on point today. So we're talking about interaction models today. This is a pretty big one. In the scope of the semester, these are the tools we've been stacking concepts, stacking skills all semester, and some of the real payoff happens at this point in the semester. These are things, these are not simple ideas, but hopefully at this point they feel simple because of the work we've put in. Last class, we walked through categorical control variables. So I asked you about two hospitals. This was right after the mini exam, so your focus was probably on what you wished you could have done differently on the mini exam, which is how it always went for me on exams. But this was the picture. I had two hospitals. You told me which one you liked better for survival rates. But then I told you, it turns out we actually have, when we break the cases out by severity, it turned out that hospital B was the better hospital by case. This is what we call Simpson's paradox, and the reason we see this is because we had hospital A having more mild cases than hospital B. I included this figure for Casey. We have two pie charts. This is the last time you'll see a pie chart in any of my slides. Actually, this is, I think, the one case where pie charts are an effective visualization as percentages of a whole of a binary categorical variable. So the reason hospital A looked so good, despite having worse survival rates by category, is that there were just more mild cases. So thinking about the subcases ended up complicating our story and actually flipping which hospital we prefer. This was an example of what we call Simpson's paradox, which indicates to us that we need to carefully consider other factors when we're looking at relationships between variables. So this is what we're doing in part 5. We're thinking about control variables. So how do we add complexity to our models to account for these kinds of things? So we turned to one of my favorite examples all semester, which is the gender wage gap. So what we did last class was use census records directly from the Census Bureau to answer these two questions. The first one was whether there was actually a wage gap by gender. And then the second one was sort of a little bit more complicated, which was just like with, or similar to the hospital example, when we look at returns to education, so once we control for education, does the gender wage gap persist? And we found that it did. We know there are differences in who gets college degrees, and our question was essentially, when we look at college degrees, does the gender wage gap persist? What we're doing today is adding some complexity to this model. We did two models last time, and we found the gender wage gap in both of them. But what we're going to do is ask somewhat more complicated and interesting questions. This was the basic model we did. So this was like a part 4 concept. So we were thinking about a categorical control variable. We had 2 categories, which is unfortunately how the Census Bureau asks these questions. They ask, what's your sex? And then they give you 2 options. There's a movement to change that, but it's not going to happen in the next couple of years, unfortunately. But this is the data we have at our disposal. So this is what we're using. We have female and male. And we said, let's set this up as a binary predictor variable on the horizontal axis, and then the vertical axis, which I have not labeled, sadly. I still have not labeled, is total income. So this is something we have accessible to us in the Census Bureau data. which you can use in your final project. I'm going to show you how to do this in a second. And what we did is we built a model that tried to explain the difference between the two groups. This is a stylized picture. The real data looks a little more complicated, but this is a pretty good model. And this was a part 4 concept, right? This is, we have a binary predictor variable. We have an intercept term. We have a slope coefficient that tells us what happens when we go from 0 to 1, which we can think of as a slope, or we can think of as just a difference on the vertical axis. Because we're dealing with 0 and 1, these are identical concepts. So this is the basic gender wage gap model we can build. But then, and so we interpreted beta 0 as the average wage for the 0 group, which in this case was female. And then beta 1 was the additional income for those in the 1 group, which was male. We sometimes call these fixed effects, and this is what we did. We walked through and built that model in code. So then the second thing we did was try to control for education. So maybe what's going on is that there are differences in who gets education. And maybe, I mean, we know that there's a relationship between education and higher incomes. So maybe there's something about differences in education that is leading to this gender wage gap. So maybe men are more likely to go to college, and if there's a bonus associated with college, then maybe that's the source of the gender wage gap. It turned out that was not what we saw. But according to the Simpsons paradox, that may be a potential, and it's definitely something we need to consider. So what we did is we first built just a simple model explaining explaining education in terms of years of education. Did I say that right? Income in terms of years of education. And then we built that statistical model. But then, like we did at the end of part 2, we added hue to our visualization. So we have 2 categories that we can see separately on the scatter plot. And the question we might have is whether the gender wage gap persists after we've drawn separate lines through these data points. So we have 2 groups. Let's set up a model that allows there to be differences on the vertical axis across these 2 groups after controlling for education. And what we saw is a model that looked like this. We had a base wage, and then we had an additional wage gap. So this was the basic wage for the 0 group. Then we included a separate intercept term for the 1 group, so the male group. But then we also allow there to be a slope. So a slope running through the data for both of our groups. We forced this to be parallel lines. So we forced the returns to education to be identical across our 2 groups. And that's part of what we're going to change today. So we're going to allow there to be different returns to education by group. But you'll remember what we found. We found that using this model, we found that there was a gender wage gap that persisted even after we controlled for education. So this beta 2 turned out to be positive, which meant on average, if you were 1 in the data set, so male in the data set, you had a higher base income, indicating the presence of a gender wage gap, even after we controlled for education. So what this means is 2 people of different genders, both with the same level of education, we still saw a gender wage gap. Okay, so this was the model. So beta 0 was the base wage for those with no college education. Beta 2 was the gender wage gap itself, and then beta 1 was the parallel lines, which were represented the return to education, the income return to education. And this was the code we developed. Okay, any questions about that? That's all prelude for what we're doing today. We're introducing a more complicated model. I'm not just interested in whether there's a baseline difference in the gender wage gap. I'm also, as an educator, very interested in whether there are different returns to education by gender. So what happens if we allow the slopes to be different? So what we're going to do, I'm first going to just introduce the model. We'll talk through its details. Then we're going to go to Google Colab and actually build a final project from scratch. Does that sound fun? Okay, love that. The correct answer is always yes. Yes, Taylor. We built our first two models. The third model we're going to work with, and there'll be a fourth one, but we're going to focus mainly on the third, is whether there are different returns to education. So we established the presence of a gender wage gap in our data set. Are there differences in the returns to education? And if there are, what are they? So this is, the picture of the data. What I want, though, is not for there to be parallel lines. So remember, building a general linear model is really all about just drawing lines through our data set. You construct the visualization in an appropriate way, so then all you need to think about are what the lines are and then how you translate that into a statistical model. So here's our data set. I have two groups, and I want to check whether the slopes are different. I'm going to show a picture. If I'm looking at this and I'm thinking about the picture, I just draw lines that look like this. I'm going to force the base wage to be equal across my two groups. And then I'm going to allow the slopes to be different. So I'm going to say, maybe it's the case that the male group has a steeper slope. So as years of education go up, maybe income goes up faster in the male group than the female group, which requires us to develop two slopes, to estimate two slopes. The first one is for the male group. So how do we, so we're going to first estimate, for the female group, just the line through the female data. But then we also separately want an additional slope, which is the difference in slope between the two groups. So when I'm thinking about this, I definitely want a beta 0. So I'm first going to write down a beta 0. For our model 3, we're going to assume that the base income is the same across both groups. We're going to relax this in model 4. We'll have two different intercepts. But for now, just to think about interaction terms, we're going to require the intercept to be the same for both groups. So beta 0, we'll write beta 0 down. The second thing is we want a relationship between education and income. And we want it to be like a baseline relationship, and specifically for the 0 group. So what I'm going to do next is write down just a numerical predictor variable with beta 1. So I'm just going to write down education times beta 1 to give us a relationship between the two variables, education and income. But then I want a separate slope that's a slope just for the 1 group. It's like the additional returns to education for the 1 group, which in this case is male, which is going to give us a beta 2. So these are the three components. I need an intercept term, I need a basic slope, and then I need a specific slope for the 1 group. And when I write that down, it looks like this. So I'm saying I'm going to try to predict wage using an intercept term plus a slope predictor. So beta 1 times education, which gives us the slope for the 0 group. But then I had this variable male, which is 1 if it's male and 0 if it's female. And I'm multiplying that by education. And that will be my predictor variable. So I'm only using education if I'm looking at someone coded as male in the data set. And I want a slope just for those people. And that's going to give me my beta 2. Any questions about this? So this is the model we're going to run. And this will give us different slopes. So it's going to give us non-parallel lines through the data, while forcing the intercept to be 0. And the way we would interpret this, we have beta 1, which represents the female return to education. So how is education associated with wages? And then for beta 2, this represents the additional return to education for those coded as male in the data set. And then the total education effect for male is the sum of beta 1 plus beta 2. So that's the slope of the green line. Okay, any questions here? You want to fit this data? Yeah, Wyatt?
Notebook's not.
There's no notebook. Yes, on purpose. Should we build this from scratch? Okay. So we're going to treat this as a final project. I think this is not something I've seen students do in the past using this data set, although I have had students put together excellent projects on the gender wage gap. But if I were putting a project together for this class, this could be one. So I just want to show you some of my thinking for putting this together. And we're going to continue working with this a little bit later. So, so I need a data set. So if I'm a good Econ 0150 student, I'm going to go to the final projects and look at these data sources. So this is just a document I've pulled together. You've probably seen this before as you're exploring your data sets. But this is just a list of lots of different sources for data. So this is, the Federal Reserve of St. Louis. They have lots of great data sets, like CPI, so like inflation, which is a big deal right now, GDP, exchange rates, another pretty big deal. Lots of different variables here. You can search and find lots of these different things. World Bank open data. So there's we've actually used World Bank data as some of our examples this semester. Any variable that had countries and GDP probably came from this. This is a great place to start if you're interested in like international kinds of things. There's lots here. So Bureau of Labor Statistics, you've probably looked through these. I've had students, I had a great project last semester use MIT Election Lab. And we actually use this in part of our, I think it was part 2. So lots of really great stuff here. MIT Election Lab has records on elections going back to 2000. So vote counts by county, vote counts by precinct, like vote counts by state, tons of great data. And sports stuff. So if you're into sports, I went to a bar once to watch a Steelers game, and the bartender was like, go sports ball. That's what I think of when I say sports. So there are also like property value stuff. So you can find Zillow research data, which they publish. I've had students use this. Very, very interesting. Redfin is like Zillow, but different. They also publish data. So lots of great stuff here. What we're going to do for a second, I just want to walk you through IPOOMs. Anyone heard of IPOOMs? correct. That is the correct answer. iPooms is actually an incredibly powerful website. They collect primarily individual level records. The iPooms USA is the one I've used for almost a decade now. What you can do is create your own data sets, and it's built off of the US Census. So what we're going to do is I want to show you a few things. So we're going to create a custom data set. The first thing is we can look at samples. And this may look fancy or complicated, but I've had many students in the past use iPooms data in their final projects. In fact, I had a student last semester estimate average incomes by major using iPooms data. So if you want access to that data set, I've even posted it in this replication notebook. So you can actually just access the data set that this group used last semester. So you can load it here. It's pretty amazing. So let me just show you the kinds of variables that are available in iPooms. I know I'm putting you all to sleep, like we have a sound machine right there. And we're talking about iPooms. But let me just show you, like, census records go all the way back to the 1800s. So if you're interested in historical data, we have a lot of economists in our department who use this to talk about history. So you can use, records that go all the way back to the 1800s. What I often will do is just use the most recent ones. So the data we have for the gender wage gap, I just downloaded it from 1999. Nope, 2019. So you can select which years you want. And then what we can do is go to the specific variables that we're most interested in. So if you're interested in education, you can go in and select the kinds of education variables you'd want. So like degree field, for example, is one that Ruby and her group mate used to estimate the average income by college major. Yeah, James.
When I was working on my parkour project, I was going to use some iPhone data.
Yeah.
But I was going to ask, is there a limit to how much a regular computer can handle? Because I tried to do multiple decades. I tried to do like 2 decades worth of data.
Yeah.
And it made my computer, especially in Colab,
Yeah.
So you like.
That's a great question. So yeah, iPooms can easily eat up your Colab resources. One thing you can do is get a subsample. So not the entire data set, but just like a couple thousand observations, which is actually what we're doing with the gender wage gap example. So to download these records, even 2 years can be gigabytes of data, which is often challenging to handle on a computer. Yeah. But something we can handle that's more of an advanced tool. But if that's something you're interested in, definitely come talk to me and we'll figure that out after class. Okay, any other questions? So anyway, I don't want to get too deep in the weeds here, but if you're interested in playing around with these things, there's a lot that you can have access to. And this is where you can learn about the variables. So you can pick up the codes. So this is school attendance, and then you can see what each one of the variables means. So if it's saying 9, that doesn't mean you went to school 9. It just means you were missing from the data. So you can get the details on what each variable means and what the codes in the variable mean for your particular question. So that's where I got this data set from. I made it available to you under exercise 5.1. So what I'm going to do is just download census records. So if I click on this, nope. So it's in my downloads folder. And if I bring it up, you can see it looks like this, which is exactly what we saw in the notebook last time. Speaking of the notebook, have you all seen Ryan Gosling in the new movie? Okay. Even Casey doesn't like that joke. Neither do I, turns out. Put that one in the trash bin. At least I tried. So I downloaded the data set. We took a look at it. What we're going to do is actually just open it up in Colab. So I have it in my downloads folder along with other nice little pictures of Maxine. This is all I have in my downloads folder, just pictures of Maxine. And census data. That's what my life looks like. So what we're going to do, if we're just starting off with our final projects, which I think nearly everyone in this room is already deep into your project. I think having a part 4 completed is most of the way there. There's still a lot to do, but you've done a lot of the hard work. But if I were starting this, I would just start with a notebook that looks like this. So I gave you sort of a basic setup here. I'm going to save a copy. And so I have that copy. I want to locate it in Drive. And it turns out it's just right in my Colab Notebooks folder. This is a wasteland, largely because I have 2 classes that I'm organizing. So I don't keep this particularly organized. I hope yours is more organized. But what you can do is just rename this to be whatever you want. I actually created I created a folder called Final Project 1 p.m. What we're going to do is create a similar project. So I'm just going to create a new folder. We'll say Final Project. And I just want to move my my Final Project notebook into that folder. So I'm just going to locate this in Drive. So I have it here. I'm going to rename this. Let's call this Final. And then I'm going to move this into the folder. I like using folders because it keeps everything sort of organized. Like the notebook will be right next to the data set. I would recommend you do the same thing. So I'm just going to go down here to organize. I'm going to go to move and then move it into the final project folder. So when I double click on this, I just have the notebook that we're working with in an empty folder. Then the next thing is I need the data set to be on Google Drive. So what I'm going to do is just drag the data set and upload it into Google Drive, which looks like this. This is a 1,000 observation sample. This is not the entire thing. If it was the entire census records, this would be gigabytes, and then we'd run into problems. So then I'm just going to rename this. I want to drop the 3 on the end. Okay, so this is the project. The first thing I'm going to do is try to get the data set loaded. The first step is just to mount my Google Drive. So this is just going to run this. It's going to ask me to log in, connect to Google Drive using my personal account, and then we're going to let it load. So this is just going to mount Google Drive. The second thing is I want to point point the notebook at my folder. So I called the folder that we're working in Final Project. And then I'm just going to run this. So this just sets up the notebook to look in the Google Drive folder that we'd set up, if I named everything correctly. And then I'm going to run the imports, and then we just want to load the data set. So this is USA, and then we'll check what it's called. USA sample data. Sample data. And if we've done everything correctly, this will load, which it has. And then we can just see what it looks like. So this is my data set. This is the process of going from nothing to data set in Google Drive. It takes about 3 minutes. I've given you all the steps to feel comfortable doing this. If it takes you more than 10 minutes to do, send me an email and I'll help you bail yourself out. There's a lot of confusing ways of approaching this. There's one very simple way, but often I see a lot of people get stuck on this, and you really don't have to feel frustrated at this point. Okay, so this is the data set. The first thing I want to do is prepare some extra variables. I'm not going to save the data set, so I'm just going to comment this out. What I actually want is to create 2 variables for our purposes today. The first is I want a natural log of income. So I'm going to say data natural log, so log natural of income is equal to np.log data. And then I need to figure out what my income variable looks like. That's just income total. So I'm just going to copy that column, call that income total. And then the second thing I want is the variable male. In my data set, I have sex, which is 0, 1, which is 1 if you're female and 0 if you're male, which is totally fine to use. I think sex is the least, is not the most informative of variable names. What I want instead is to name it according to the category. So in this case, you could either name this female and just redefine sex as female, or you can do something similar but for male. So that's what I'm going to do here. Data, male, and then we'll set this equal to 1 minus data sex. If I run this and then take a look at the variables, data.head, and we can see what this looks like. So just for the header, we have male, we have education, which is going to be important for us, and then log income. So nice. So we're all set up. We have the variables we need organized in the right way. We could use log income 10 if we wish, but that's a little bit harder to use. So that's why we're creating the natural log income. It's a little bit easier to interpret the regression, the output. Okay, so the next step, we spent all of the beginning of the semester, do you remember that? Setting up data visualizations. The reason we do that is so that we can understand what's in our data set before we start building our statistical models. So the first step for me will be to do some exploratory data analysis. The first thing I want to do is try to understand the distribution of incomes. So I'm going to do sns.histplot data x is equal to log income, ln income. When I run this, dramatic pause, I get this. This is the distribution of log income. We can also see the distribution of just incomes total. So we could say income total and plot this. Here you can see the distribution of just raw incomes in our data set. Many people make not that much money, and very few people make lots of money, which follows this sort of power law that we often talk about, right? Like, very extreme events are very unusual. Very small events are very common. This is a classic case of requiring natural logs, or logs in general. Doesn't matter what the base is. So that's why we use ln of income. This is going to be our outcome variable. The next thing we might want to do is plot the distribution of education. So how many years in college have you been? So let's do sns.histplot, and then we'll do data x is equal to edu. And we'll plot this distribution. And this looks very different. You'll notice a couple of things. This is the reason we do data visualization, is so that we know what's in our data set. Here I have a lot of people with 9 years, 10 years, 11 years, and then a lot of people finishing high school at 12. Then we also have some people with 1 year of college, so 13 years. We have slightly fewer people with 1 more year at 14. Then we have a gap here, which is like 3 years of college. We don't have anyone in our data set with 3 years of college. Then we have a lot of people with 4 years of college, and then more than 4. When I look at this, I think maybe there's something going on with the way that the data has been coded. I'm certain that there are people who go to college for 3 years. When I look at this, I think maybe the census just isn't recording, maybe there isn't a category for going to school for 3 years. And so maybe it's just not reporting that, which could be showing up here, which is a limitation of our data, and we would not be able to easily see this without doing data visualization. The other thing I'm noticing is that, like, I've gone to school for more than 17 years. I know it's sad. But if I was in this data set, there's no one in this data set who has more than 17 years of education. And certainly there should be in a population of 1,000. So probably what's going on is everyone with a master's or higher gets coded as 17. So it's like 17 years or higher. So that's what we're looking at here. This is how I would understand it. And this is important context when we run our model. Any questions here? So then the next thing we're going to do is figure out the gender breakdown. So what I'm going to do is SNS dot, y'all remember? SNS dot pie plot or pie chart. Well, it turns out Seaborn doesn't have a pie chart until Casey writes one. Let's do count plot. So count plot. And then data, and then let's do this. So here we have the breakdown by gender. So it leans slightly towards female, but we're pretty close. Any questions here? So this is reassuring. This generally matches the population at large. So the next thing we want to do is use these variables to build a statistical model. The first thing I'm going to do is just plot the relationship. So I'm going to say SNS dot scatter plot, and then I guess we could just plot out this relationship. So this is female and male. This isn't our main variable, our main relationship of interest. So maybe what I'll do instead is plot education on the horizontal axis, which looks like this. Here, it's hard to see what's going on. I'm going to add hue for male to give us 2 different colors by gender. And then, let's see, can we do an alpha 0.1 just to get a sense of the relationship. So when I look at this, I see a positive relationship between education and income. The gender part is a little hard to see on this figure, so maybe we try something separate. That other thing we could do is a LM plot. So LM stands for linear model. So when you're thinking general linear model, that's what this is standing for, general linear model, LM plot. And then it's just going to build a linear model behind the scenes. So we get our lines. We don't have a lot of flexibility in controlling what the linear model is doing. but we have a nice figure with some lines on it. So here you can see that in our data, the male group is slightly higher than the female group. Any questions here? All of this work is to get us to a place where we can appropriately apply our statistical model. What I'm going to do is write down the model with separate slopes. So is there a differential return to education by gender? So I'm going to say model 3. So we did model 1 and model 2 last time. And then we're going to do smf.ols. And then we're just going to write down the model. So this will be, we're trying to predict the log of income with, we're going to include an intercept term, which comes for free. Then we have education, so edu, plus education, but for the male group. So we need a separate slope for the one group. So I'm going to interact this using this colon with the male group. So this gives me a separate slope, a separate relationship between education and income for the male group. This is just identical to this thing. So we're just multiplying education and male. It's just the notation for that is this colon. Any questions about this? And then we just want to give it the data and ask it to fit, and then we're going to print out the summary. And then if we put it inside a print, it looks like this. Okay. So we are, 47 minutes into class, and I have not asked you to interpret anything. I've just talked to you for 47 minutes. How sad. So I want you to pause, think about what this model is telling us, and maybe tell your neighbor you believe the weather will get nicer, and then tell them how to read this model. We'll take maybe 2 minutes here, and then we'll talk about this together.
There are things that you did. Yeah, actually, I'm gonna try that. But we're not that far. We're doing exactly. And okay, it's one of those. And they use today for this. I mean, they didn't use it for they use it for as office.
Okay, what do y'all think? Someone want to interpret this 7? Ryan.
So the 7.2049 is the expected income level if with no education or less than non-education.
Yeah.
And then the EDU is
Okay.
the slope for women
Yeah.
as they go up 1 year of education. And then the EDU male is the slope increase from that 0.211 for men as they go from 1 year of education.
Perfect. So each one of these coefficients is our estimated value in our model. And just like Ryan interpreted them, the intercept is the average income of the of people with zero, so 0 years of education. This 0.211 is the relationship between years of education and income. This tells us every year of education is associated with a roughly 21% increase in your earnings. Like we talked about last time, this is not causal. There are lots of reasons why people who go to college make more money that are not causal. So the higher your income, or the higher your parents' income, the more likely you are to go to college. But also the higher your income is, the higher your parents' income is, the higher your income is for reasons independent of your college education. So that's a story that could explain part of this. But if I'm doing my job, then that shows up in this number too. We just don't know that this is actually causal. And then the last part is, but this is for the group coded as 0 in male. So this is for female. This is the specific slope associated with the male group. So this is an additional return to education for those coded as male. And what this tells us is there's an additional roughly 3.5% increase per year of education, but specifically for those in the male group. And what we see is this is drawn from the sampling distribution around our null hypothesis. We would see this roughly 0% of the time. So this is strong evidence against our null hypothesis. This is unfortunate news. What we're doing with these statistical tools is allowing us to see these things that exist in the world. It allows us to measure, and that's a powerful thing to have at your disposal. Any questions about this? Yeah. Yes. So I have an entire slide devoted to this. We'll get there in a second. So Darren's question is, why are we interpreting these as percentages? And the reason is because the outcome variable is a log. So because we're using log of income, the interpretation of the betas for income is in roughly percentage terms. So we could just say education, every additional year of education increases log income by exactly 0.21. But if we want to make claims not about log income, but about income directly, then we can talk about percentages, which is part of why we do this log. But we'll come back to this in a second. Yeah, great question. Any others? All right. So this is a powerful model. It allows us to see this, which is something you as training economists are now capable of performing these kinds of tests. Okay, so so this is the the conclusion. This is model 3. So let's talk about, this is, I think, to answer Darren's question, why are we using logs? The reason is because of this problem. If I give a $5,000 raise to someone making $25,000, their income goes up by 20%. But if I give a $5,000 raise to someone making $200,000, that's a much smaller increase in their income. And one thing we're interested in is sort of having consistent scales for these things. So we would think the effect of income would be multiplicative, so a percentage increase. And what a log does is allow us to talk about percentage scales. So like we did just now, when we're using log incomes, we think of the betas as percentages of the thing that we're taking a log over. So I would say the beta, so beta 1, would be an increase just linearly in the log variable. So every additional year of education, we see the log income going up by beta 1. But we can also make percentage claims about income in this framework. So we can say income, not log income, goes up by beta 1%, just like we did. Which is why we do this. It solves kind of two problems for us. Okay, any questions here? This is only true with natural log. You can use other logs, but they're more challenging to interpret. Use a natural log. It's just a little bit easier. Okay, so that's really nice. So yeah, here's two examples. If beta 1 was equal to this, that would be, we would interpret that as income being 8% higher for every additional year of education. And then for this number, it would be interpreted this way, an additional 3% per year of education. All right. Powerful model, troubling results. This is what allows us to measure in the real world. And this is actually how we do it. I'm not giving you like a dumbed down version. Okay, any questions? You all want to talk about your final project? This is another model we could build. We're going to skip this, take a look at this in the slides. But you can build a model that gives both different intercepts and different slopes. We can extend these models however we like. Here, this is a model with different intercepts, but also different slopes. And it looks like this. We're just combining model 2 and model 3. Model 2 we did last time where we had an intercept term, beta 0, but then we had additional returns to education, so just a slope. But in model 2, we also had different intercepts by gender. So here, this is the model 2 component. But then for model 3, we also added different slopes. So a specific slope to the male group. So we could add that on the end here too. So each one of these pieces is just adding a different component to the way we draw our lines. And then we can estimate these with our data. If you are not amused, I hope you've enjoyed at least some part of this class, but to me, this feels like truly powerful tooling. And I hope you feel the same way. All right, should we talk about the final projects? You can take a look at this if you like. So let's just talk about the final projects. We're going to spend the last 15 minutes. I have nothing else planned. I want to talk to as many of you as possible over the next like 2 or 3 weeks as you're like finishing up your projects. We are in the countdown towards final projects. Yeah, Bridget? There's no exercise today. Yep. I meant to do attendance, but I think it's not worth doing at this point. Do you want attendance? Okay, I'll put it up at the end, and you can sign in if you like. Um, uh, so I have the guidelines page here if you're interested in looking at this. We have a Part 5 project coming up. But the main components of the final project will be the written report. So that's going to be 1 to 2 pages. This is, I think in general, you should not think of this as like a paper. You're going to simply organize what you've done in 1 to 2 pages. But I'm not looking for like a big essay. This is just tell me what you did and tell me what you found. This is a bit of an outline. We'll talk more about this once we're through Part 5. I'm going to give you a demo of how I would put this together, just so you get a sense of what I expect these to look like. This is very short. And then the presentation is, some people can get away with 3 slides. I recommend either 1 or 2 slides. This sounds easy to do. 1 to 2 slides is the hardest thing to do. You want to communicate everything you've done, but very simply. And this is a very challenging skill. So we're going to talk through how to do this, and then you'll present during the final exam period. So I think the registrar has posted these. I'll send out more information about this, but you can find this in PeopleSoft. So what I want to do with the final projects over the next couple of weeks is end up having a conversation with almost everyone, either in the class, like after class or during these kinds of periods, or in my office during office hours or whenever. I just want to check in with everyone, make sure you're doing okay. If you have questions, sort those things out. But we're going to start adding sort of time at the end of class for projects and questions and such. So that starts now. This is all I have planned. I guess we'll put the Top Hat code on the screen, and then I'll see y'all on whenever the next class period is. I'm tired. Are y'all tired?
Yeah.
Is 5 o'clock late for a class for you?
Yeah. I had a question.
Yeah.
So when I was working on my parkour project, I like switched my question several times.
Okay.
Depending on A, the amount of data that was available,
Yeah.
and B, the ease of being able to import that data into Colab. And so whenever I work on projects, you have office hours and projects. So whenever I work on my projects, I'm just going to go to your office hours without visas. I wanted to do like, I had like one course I was working with crime statistics, with influence with voter distribution.
Yes.
I have to learn how much
Yeah.
and then I tried to do the crime
So like by geography?
by state. Yeah, I did it by state, but it was like all the data was probably like state by state. And then I went and I was trying to use all the data, even data that was inside of the it worked, but it was like hard to correlate.
Yeah. I think the margin would be challenging.
I'm pretty sure this is
What I did housing,
or it's like it's a
voter distribution
Yeah.
by state. And so I did that for 4 years. That was easier, but it correlated a little bit, but policy how you go about it. It's a lot of factors. So it was like hard to see. But I wanted to do something that was more like you can see it.
So you're trying to figure out a predictor for voting.
Yeah.
Yeah.
Yeah, I wanted to know when your office hours are, so I can come in and like. These are all.
Yeah. Friday 10:30 to 12:30.
Okay, I'll be there. If not this Friday.
Yeah, there's a lot you can do there. doing it at the state level is going to be kind of challenging. One thing you can do is look at one state and go by county.
I do have the county level data as well.
And that might be a better option. Part of the problem is like Pennsylvania and California are very different from non-small counties. But like Allegheny County and Butler County are different, but they're like more similar. If that makes sense.
It's like within states will tell you more about.
Well, this was the issue with that is,
It's just like, there might be different or more similar compared to two different states.
And what you could do also is like you can look at two different states. You could include Pennsylvania and like New York, and look at, let's say you have crime statistics by county and voting statistics by county. You could look at the relationship between those two variables by county, but then also include different slopes or different, like you could do these kinds of interaction things with that kind of model. Does crime predict vote share more in New York City or in New York State than it does in Pennsylvania or something like that?
Okay, I'll probably try something like that. So it was 13. Like I said, I'll definitely look you up.
Yeah, sounds good.
Which are 24 or 24.
Yeah.
I looked on Registrar, and if I'm reading it, it looks like it's so it's like, yeah, I think I have 16. Oh my god. It's like I could run this, I guess, on my desktop, but it's like I cut off like 5 years of my entire system of life, and you want to have that on there. Yeah. I don't have the right CPU or TCU or anything like that. And we were never given computers, so it's like, yeah, and we gotta take that to Jordan. Because it's like, we were never given computers. Wait, in fact, she told us that we weren't really sure how to teach them. What? I think I can get to finish at least. I might be able to get to 5.7. I know. You do SEM to find the most valuable features, and then you eliminate regressively with SEM. This study had great I would love to put it in. Honestly, I would have worked on it.
Spot wet 133. Yeah.
High up.
I thought it was just like
with tenfold cross validation.
I imagine they use SBI workers.
And it was the same with CC2. I'm pretty sure like 99.66% average accuracy. I'm pretty sure that ISDN was like the one that's like noise reduction, like I know. Yeah, the global filtering and noise reduction, and okay, come on, like if they're getting 99.6% average accuracy, and it's like if she has this end of the study, that means like we kind of just have to start all over. And it's like we have literally because of whatever she's able to do, they also like I doubt it's because she said that she's going to look at it, but study so the earliest we can probably meet is like if I just sat.
They do.
Yeah. And like
So one thing you can do is,
or we meet Friday, and that means we have a week because then we also have to write her a do the posting Friday.
Oh, we got automatic count.
and then do the paper, also do
For Pirates fans?
for the capital. No, there are some cards that.
Well, that's true, but if we talk to Jordan,
What?
I think that's the one.
Yeah, you've seen this one?
Yes.
Yeah.
Write that paper.
I don't remember if they, let's see, vote share and then total votes. Yeah, so they're looking at like county size. But if you did income, I think you could set up something that looks a lot like this. I mean, different question and all of that, but it'd be, yeah. So you're looking at total turnout, so that'd be your vertical axis. So turnout rate, and then maybe county income on the horizontal axis. And then you could maybe break it down by like if it's above 5 on your scale or if it's below 5, and then break out 2 different lines.
Yeah. Make it
That might be
binary.
so that might be one way of doing it.
Okay, that works, yeah.
But those are just some ideas. It doesn't have to be that.
And it's like we don't
Just some
have
ways
that.
of
You don't have that. The
thinking about
one
it.
demand
Okay.
compute.
Also, just really unrelated question. The final exam period is this, right?
Yeah.
Okay, cool.
Sad.
Thank you.
If it's like a little bit less than, or anything around it.
Yeah, it would probably still take like at least